Hi everyone. Today you're going to learn about a radian measure, which is a way to measure angles that is a little bit different than degrees, but something you'll need to know as you move forward in mathematics. You have a handout that we were going to use, but since I'm not there today to actually do the activity with you, I'm just going to show you a kind of a modified version of what it was going to be, and then you can work on your homework for tonight after we're done. Okay, so what we were going to do is I was going to have you measure the the circumference of a circle using a piece of string. But since I'm not there to describe it to you, I'm just going to kind of show you what this would look like. Okay, so here we go. Angles measured in degrees or in another angles can be measured in degrees or in another form. That form, as you hopefully just heard me say, is called radians. And there's a reason it has the name radians. Okay, so the first thing that you would have done is you would have measured just a circle. And we're only going to work with the circle on the left, so I kind of cut out the other side. So you would have used a piece of string. So I'm going to kind of pretend like I have a piece of string here to measure the radius of the circle. So this would be the radius of the circle. And we're just going to call it 1, like 1 radius, like the unit circle, right? Then you would have picked up that string and you would have used the string to mark off what are called a radian measure on the circle. Okay, so instead of me trying to eyeball it, what I did is I created another circle that I'm going to lay on top of this one. Okay, so you can see that it's the same size. And here is the 1 radian that I was talking about that I highlighted before. If I were to take that piece of string or that measurement and lie it along the outside of the circle, along the circumference, it would have this length, okay? So it's the radius, and then that radius is kind of on the outside of the circle as well. And this is also the radius over here, okay? So these two radii with the radius then curved along the circumference of the circle, these things make what's called 1 radian of a circle. Okay, so this is 1 radian, and it's about 57 degrees of the circle approximately. Okay. All right, so now what I'm going to do is I'm going to spin this circle so that I can figure out how many radians we actually fit in one circle. Okay, so you would have what you would have done in class is taken the string and measured it off, which I guess I could probably do that as well. So let me take another color and put it across the top of it. So if I just measure this string, this fake string right here, okay, and I try and move it, see the problem is the spinning, right? So if I were to try and move that string around the outside of the circle, then we would be creating more radian measures, but that's going to be too complicated for me. So instead what I'm going to do is what I just described, which I'm going to spin this circle. Okay, so I'm going to spin it so that I'm lining up the radius from the original way the circle was laid out with the one that kind of ended the first radian. So this was 1 radian. Now I have a second radian measure. So let me highlight that here. So this is where the second radian would be. So here's 1 radian. We'll use R to represent it, capital R. And then this is now 2 radians. Okay, so kind of follow along and maybe even trying to estimate it on your own paper as you go along. Okay, so I'm going to spin again, trying to keep that center in the center of the original circles. Move it a little bit here. So now you can see I now have, let me turn a little bit more. Now you can see I have 3 radians, and 3 radians is almost half of a circle. So 3 radians here. Okay, and I'm going to spin again. Recenter that a little bit. Okay, so now I can see I have my 4th radian here. Let's spin that again if I can find my spinning part. Here we are. Try and recenter that. Okay, so now I have 5 radians. And then the last, probably the last bit here. Spin again. Okay, so we can see our, oops, get that off of there. Let's pick purple this time. And now I can see this is my last full radian I can get. So I have 6 full radians on this circle. Let me move the overlying part out of the way. So I have 6 full radians plus this little bit extra. And here's where it gets really interesting. So this little bit extra turns out to be the little bit extra that you get if you were to think of going around the circle or thinking about how much. I'm just probably going to have to give it away to you. Okay, so it's basically how much what happens when we work with pi. So if you are aware that pi is approximately equal to 3.14, okay, so we know that this spot right here on our circle, because we've talked about this before, this is pi. Okay, so half of a circle is pi, which do you see how we went to 3 radians and a little bit more? We actually went to 3 plus 0.14159, da, da, da. So the first half of the circle is pi because it's 3 radians plus that little bit more. And then the second half of the circle is the second pi, if you will. So over to here, we're now at 2 pi radians, which again, pi is about 3.14, which means going all the way around the circle is 2 times 3.141, da, 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 which is equal to, so 6.282, etc., etc. So this little part here is double this little part over here, or it is double the pi. The whole thing is double pi, but you can see that the way this all works out is you end up with 6 plus a little bit more radians. So when we go to figure this out, when it says how many radii are you able to mark off, it's going to be 6 plus a bit, if you will, okay, or 6 plus 282, if that helps. So what you're able to get in the total circle when you mark it off, approximately how many radii are you able to mark off? Well, you can actually say you are able to mark off 2 pi radians. But that is the same as actually 2 pi radii, and that is where the name radians comes from. It is representing the fact that we are finding the number of radii that can go around the outside of the circle. Okay, so that's all the information that you would generally get about where radians come from. Now we're going to actually talk about what you do with them. So for now, we're going to be focusing on going back and forth between radians and degrees, or degrees to radians. So you have to be able to understand the difference between the two and how to go back and forth, but it's all going to deal with using pi. So the first thing that we're going to just remind you of is that the circumference of a circle formula is 2 pi r, and we're going to need that in a little bit. And if you want to change from degrees, so this is our formula. So this is to go from degrees to radians, okay? So let's add that to your paper. So if you want to go from degrees to radians, you're going to use one of these two formulas. Really, you're going to use this one, okay? If you want to go from radians to degrees, we can even add this here, but you don't need it till another page. So if you want to go from radians to degrees, it's the reciprocal of what we've got here. So it's going to be 180 over pi times, we're going to call it r for the number of radians. Okay, but some of these you're just going to want to know. Like you're just going to want to know these without having to actually do the work of changing around. So remember when we talked about going around the circle all the way, that's around the circle is 360 degrees, which is also 2 pi, okay? And that means that going halfway around the circle, which is 180 degrees, is then equal to pi radians. But that would also work if you put it into the formula right here. So if you put 180 in for n, then you would get pi as the number of radians. Okay. So now we're going to, let's actually skip 3. We'll do 3 and 4 in just a minute. And let's talk about 5 and 6 first, because we were just talking about converting. And then we'll go back up and do this part. So if we want to convert from degrees to radians, so you're going to, again, use that formula that you just wrote down, which is pi over 180 times we call it n for the number of degrees. You might also see it as a theta as well. So either version of that is fine. Oops, theta standing for the angle in degrees. So I'm just going to substitute 18 in for theta there and simplify, and you're going to leave it in terms of pi most of the time. It's rare that you would need to multiply it out. Okay, so we're just going to leave it in terms of pi. So we're just going to divide or reduce here, and you're going to get pi over 10 as the angle in radians. Okay. Some of these you're going to need to memorize. Not this one. Pi over 10 is not on the unit circle, but we know that 150 degrees is on the unit circle. So at some point in time, you're going to have to be able to memorize these, or at least be able to quickly change from degrees to radians. Okay. So here's the formula again. So you've got pi over 180, and then you're going to multiply by 150. So we're going to do a little reducing. I'll cancel here. 15 and 18 are both divisible by 3. So I get 5 here and I get 6 here. So that means 5 pi over 6 is the equivalent radian measure for 150 degrees. And you might even want to add some of these to the unit circle that you've been filling in. You should have that one that's just has the one spot left to fill in. We've already done the degrees and the coordinates. So now you might want to fill in these radian measure as well. Okay, let's go back up to 3 and 4. So 3 and 4 are asking you to find either arc length or the radius or the angle in radians. So let me actually copy this formula and bring it down so I can talk about it a little bit. So this formula is for arc length. So what it actually is S stands for arc length. I have no idea where that came from, why they call it S, but that's the standard letter we use for arc length. R stands for radius. And theta stands for the angle in radians. Now, if your angle was in degrees when you do this problem, then you would need to change it to radians before you use this formula, okay? Or back in geometry, you may have learned it like this. S equals pi over 180 times the angle times r. So I think that's probably how you learned it in geometry, but you just need to worry about the one in purple here. All right, so let's go ahead and go up and do this. So we're just going to find the missing information in 3 and 4. So in 3, they gave you the radius and they gave you the arc length. That means we need the angle. So we're going to say the arc length is 2. The radius is 4, and we're looking for the angle. So that means the angle is 2 over 4, which is equal to a half, which means it's equal to a half of a radian, because again, this formula finds the angle in radians. So this is equal to half of a radian. If you needed this in degrees, then you would use the changing from radians to degrees formula. So you'd have to go the other direction. I'll do that on the next problem so you can see what I'm talking about. Okay, so then this problem over here, you have, this is the arc length right here. So it's a portion of the circumference. That's what arc length is. So you've got your arc length and you have your radius. And again, you're looking for the angle. But notice in this problem that this is 48 inches and this is 2 feet. So you would have to change one of them to either be feet or to be inches. It doesn't really matter. So I think I'll just change the feet into inches. So I now have 24 inches, because remember there's 12 inches in a foot. So now I'm going to set this up. I have 48 is equal to, because that's the arc length, is equal to the radius is 24, and we're looking for the angle. So now I get that the angle is equal to 2 radians. Well, if I wanted to know what that was in degrees, which remember we kind of talked about it a little bit ago when we did the picture, when we turned the picture where 2 degrees, 2 radians would land. You could just kind of approximate it in your head even. But if we want to actually find the actual degrees, then you're going to do the formula in the opposite direction. So you're going to do 180 over pi times 2. Okay, well, this isn't super nice because I have this theta in the denominator, so you're going to have to break your calculator out for this one. So you're just going to do 180 times 2, obviously, which is 360, and then divide by pi. And make sure you use the pi button and not the actual 3.14. You want to use pi. And this comes out to be 114 point, let's say 6 degrees. So I'm going to round it. A lot of times we'll round it to a whole number, but I'll go to the 10th here. I don't know if you guys can hear my cats fighting with each other in the background here. Okay, moving on here. So now we're going to go in the other direction, which is a little bit easier now because these are in radians with pi already. So you don't have to worry about dividing the pi out. So we're just going to convert these by multiplying by 180 over pi. So again, the nice thing about this is that the pi's will cancel. And so now you're literally just doing 180 divided by 9, which gives you 2 radians. Sorry, excuse me. Actually say this correctly. 20 degrees. 180 divided by 9 is 20 degrees. Just thinking of the last problem there. Okay, next one, we're going to again do 180 divided by pi. So again, I'm just going to cancel the pi's and see what I can do to make this a little bit easier to work with. So let's see, 180 divided by 4 is, I didn't prep this one, 180 divided by 4 is 45, and 45 times 3 is 135. And this is an angle on your unit circle. So this is actually a 45, 45, 90 right triangle, but now we're going to think of it as 3 pi over 4. So this is another one you could add to your unit circle. 135 is the same as 3 pi over 4. Okay, now we're going to talk about coterminal angles, but we're going to talk about them in terms of radians. So remember when we talked about coterminal angles, we find them by adding and subtracting 360 degrees. Well, we're in radian measure, and I don't want to change the radians to degrees and then have to change it back. So I'm just going to know that 360 is equivalent to 2 pi. So instead of adding or subtracting 360, I'm going to add or subtract 2 pi. So the first thing I'm going to do here actually is, for this problem, since I'm in a fraction, the denominator is 6, I'm going to turn 2 pi into a fraction with 6 in the denominator. That way I can add or subtract it nicely. So 2 pi with a denominator of 6 is the same as 12 pi over 6. So that means 17 pi over 6 is bigger than 2 pi. So I'm going to subtract that 2 pi, but I'm going to subtract 12 pi over 6. So now I have 17 minus 12 is 5. So this is 5 pi over 6. This is also a unit circle angle, if you remember. Okay, and 3 pi over 4, even though it's negative, well, sorry, I said that wrong. Negative 3 pi over 4 is clearly less than 2 pi, so I'm going to have to add 2 pi onto it. But again, I need to get a common denominator. This is why we have spent time this semester dealing with fractions. So I need a common denominator of 4. So I'm going to actually be adding 8 pi over 4 instead of that 2 pi. And so now I've got 8 minus 3, which is 5. That's 5 pi over 4. And 5 pi over 4 is also an angle on your unit circle. All right, last problem together. So now we're going to do some more arc length stuff, but these are now angles. One angle is in radians and one angle is in degrees, but you're looking for the arc length. So you're technically looking for this portion of the circumference. So this one, again, is just S equals R theta. So we're looking for S now. And in this problem, R is equal to 5. and theta is equal to 4 pi over 3. You don't have to put this in decimal. You're just going to multiply the 5 to the 4, and you're going to have 20 pi over 3 is the length of this arc right here. Okay, so now for this problem to the right, this angle is in degrees as opposed to radians. Now, if you already know what the angle is in radians, you can just change it and use the radian measure, but we haven't really gotten there yet. This is an angle on the unit circle at 60, so that it will be an angle that you'll need to know in radians, but we're not quite there yet. So there's two options. I think the option I'll take for this one is I'm just going to find that theta in radians for us. So I'll use the formula. So I want to turn 60 into radians. So I'm going to have to multiply 60 by pi over 180. Okay, so this is the formula. And I'm just going to reduce. So 18 divided by 6 is 3. So this angle in radians is pi over 3. So now I can use that pi over 3 in the arc length formula, which again is radius times the angle. And you can see that the 9 and the 3 cancel, so 9 divided by 3 is 3. And so you get 3 pi as the length of this arc right here. Okay, I think that's it. Obviously, go back and rewatch it if necessary. Hopefully you thought ahead to pause if needed to copy stuff down. And now you can go ahead and work on your homework.